So, welcome to module 8.4. In this module, we will see project 9 with more examples of project 9. So, as we see now, as we go into this project 9, we have seen the notion of average, hello world and fraction, hello world and square. Now, let us see this fraction code. Again, as you see, there is a main dot jack file and a main dot fraction. So, in the main, there is a class main which uses fraction, right, and it has to right. There is a class main which uses fraction dot new and fraction, and then there is a class fraction which has all the things that has been implemented that we have seen here. So, it has a new, a construction, it has a reduce, and then it has get numerator, get denominator, a function fraction plus, dispose of this, and then it also has printing the fraction. These are all methods, and of course, as I told you, there is a function also internally which will do this GCD, the greatest common divisor computation. So, similarly like the fraction, we also have the list. List also has two jack files here, the main file which will create the list 2, 3, 5. It will print the list and also dispose of the list, right. And then of course, there is a list class which has the self-referential structure as you see here, feed list next, and there is a constructor for that list. There is get data, get next for every element, and then printing that list and then disposing the list, all that I have described as a part of this. Now, let us quickly go and compile and execute these things. So, we can just go back to your prompt, project 9 / fraction. You can also compile project 9 / list. Then we can go to the VM emulator. We can go and load the program. So, this is still running. We can load the program here. So, we can first load the fraction. Just go to the directory, top of the directory. We need not go inside the directory and say load program. So, all the press yes for this, because we are using some of the OS functions which we have not implemented. So, this is a fraction. So, fraction dot new, fraction dot reduce, so many functions get all the functions get loaded, right. And now, we just go and execute this function on the VM emulator. So, the main gets executed, now creating two fractions as you see here, 2, 3 are arguments to that function, so many things. So, your GCD is working on this. So, as this is working, let us just recap what the fraction we were trying to do. We were trying to do 2 by 3 plus 1 by 5, which would give you 13 by 15. Okay, so let us see what's happening. Still working? Yeah, 13 by 15 got printed here. Similarly, we can also load the program corresponding to your list, load program and yes, and then run it completely. So, in case we start writing more and more programs, the way we verify whether it is working correctly or not, even this is you can use you can compile it using the compiler and execute it on the VM emulator, and that will basically tell you it is a debugging tool for us whether the tool is working. the code is working correctly or not, right. So, this is a complete debugging tool. So, see, it has printed the list 2, 3, 5 here, and now it is currently disposing it off. So, you can slowly go through the simulation and understand how the thing is working, right. So, now you understood the concept. So, why are we doing this exercise? There is not much that we are programming, we are just executing and seeing on the VM emulation, but this will basically tell the interface between the application programming language and the operating system, right. That is the most important thing. When I say, let us take this fraction as we are seeing here, fraction.new, what happens when fraction.new is executed? So, when you actually go to this VM machine, as you see here, sorry, I think I closed it. When we actually go to this VM machine, right, and when we load this file, say load program, so we go and say list, we load the entire list program here, right. We have loaded. Now, we can see that here we know all the functions, list.new, list.get data, list.get next, list.print, and then list.dispose, main.main, etc. So, we know all these programs now. So, the moment we start executing, right. So, we have come to this main.main. Right. Now, we say every statement, so list.new now got. Now, what is happening to list.new? So, I am creating a new list with phi comma null or whatever. So, what are the arguments going? Phi and null are going as arguments, and what is happening here? So, how is this executing? So, then you basically come out and find out that there is a memory.alloc that is happening here. See. So, what does memory.alloc actually do? Right? It is creating something. So, you can see the stack, you can see all these things, whatever I have described there. So, when you carefully look at this code one by one, if you start looking at this code in detail, you will understand the exact interface between the application programming language and the operating system, right. So, when the application programming language asks for certain facility, what does the operating system do on the hardware to provide you that facility, right? Like memory allocation, printing, memory deallocation, all these things, and that is something that we achieve as part of this project 9. That understanding is very crucial, right. And whenever you start doing your programming later, there is a big field which gives you lot of job opportunities. It will give you a lot of job opportunities in the few years to come when you are in your prime of the career, that is information security. When you really want to write a secure code, you need to understand the interface between the programming language and the operating system. If you do not understand that in clear detail, you cannot write a real secure code. This exercise that we do now is a very important foundation for you to do secure coding at some later point of time, and that is why we are insisting on this project 9. You are not writing one line of code as a part of project 9, but you execute this code on the VM emulator and find out how the operating system and the programming language interfaces, right. So, spend some time executing it step by step as we see here, next step, next step, next step, and see what is happening on this stack. Understand one or two programs like your fraction and this list. If you understand this 2 programs and also some of the previous programs, I think that itself will give you a lot of clue of how things work. Okay. So, with this we end up the module 8.4, and we will see more in the module 8.5. Thank you.